Let's begin by taking a look at the add instruction. I just click here on add, and we get here to see the add instruction. We don't need a search anymore. First, we can see that there is really lots of text here. Don't worry, we are going to be able to find out something from all of this text. Let's try to explain what we see. Add is an instruction that we already know, so this would be a good start. There are a few columns. The first one is called opcode. This column is supposed to describe how the instruction is encoded as numbers. As an example here, this instruction, add al IMM 8, is going to be encoded as the byte 4 and then some immediate of size byte. Having a full understanding of how the codes for the opcodes here work is a bit outside of the scope of this course. But in many cases, you will still be able to understand something from the description on the opcode column. Next, we have the instruction column. This column contains the textual representation of the instruction. This is how you are going to write it inside your source code. This is what the assembler is going to understand. The assembler is going to convert this representation, the textual representation, into the numeric representation, or maybe the instruction into the opcode. You might be wondering, what are those things? For example, IMM8. Let me try to explain briefly the different possibilities. I'm not going to explain everything, but I will explain most of the things that you are going to see. IMM stands for immediate, and IMM8, for example, stands for immediate of size 8 bits, which is a byte. IMM16 stands for an immediate of size 16 bits, which is a word, and this one stands for a DWORD. These are just different possibilities for the instruction. You have to remember that this document was written probably by engineers, and as such it is very detailed and also very cold. You will not just see add and 2 arguments. You have a list of all the different options. And this is very important. If you want to do something serious, for example, writing an assembler, you would like to know about all the different options in a very detailed fashion, like this. However, most of the time, you will not really care. You will just want to know that add allows you to add 2 numbers. And you will just try to assemble different things and see what works for you. I will not discuss those columns at this time, and I want to skip to the description column, which contains a very short textual description of what the instruction does. As an example, for this instruction, add EAX immediate 32, it says add immediate 32 to the register EAX, which is exactly what the add instruction is supposed to do. Let's move on to see what more is written about add. Here we have some description about how to encode the operands. We don't really care about this at this point, but just know that this is here. Next we have the description of this instruction. This time it is a bit more detailed. Here we had the short description in this column, and now we have a more detailed description. Let's see what it says. The add instruction performs integer addition. You can see even more detailed explanation around here. Next, here at the operation, we will usually have some pseudocode description. It will be a more program-like description of what the instruction does. And in this example, as we look at the add instruction, we can see that the add instruction just takes the two arguments, dest and source. It adds those two arguments, and the result is stored inside dest. Many times you will just want to look at the operation, because it is usually the shortest description of what the instruction does. It is not always the case. Sometimes the operation is a really complicated piece of pseudocode, and it will be really unreadable. But sometimes it will be a good option. You have to combine both the description and the operation most of the time to get a full understanding of what the instruction does. The next section is called flags affected, and this tells us which flags are going to be affected as a result of invoking the add instruction. It says here that many flags are going to be affected: overflow, sign, zero, auxiliary, carry, and parity. It is possible that you have never heard about some of these flags. This is okay. If you want to know in a more detailed fashion how those flags are being changed, you should probably read about it in volume number 1. You will not find it in volume number 2, which is the instruction set reference, where we are currently. The next section is about exceptions. Exceptions basically describe all the bad things that could happen when you invoke this instruction. And as you can see, there are some bad things that could happen. I don't want to deal with this at the moment, but I just want you to know that this part exists here. As you can see, there are many kinds of exceptions. And this is about what we can see inside this instruction. And this is about what we have on the add instruction inside this manual. Let's try to be brave at this point and look at an instruction that we have never seen before. Maybe, for example, the ADC instruction, which is just above the add instruction. Let's try to understand together what this instruction does, only from this description. First, let's look at the name, ADC. It says add with carry. Interesting. The opcodes do not say much at this point because we don't yet know what this instruction does, and we really care about the operation of the instruction at this point. Maybe we want to use this instruction in our program, or maybe we just read this instruction in somebody else's code and we want to understand what does it do. We can see that it has a very similar syntax to the add instruction. In fact, it really looks the same. There are about the same options for instructions. If we take a look for a moment at the add instruction, we can see that it really looks the same. This might be a good clue. We continue to the description. Let's look at an example at this instruction. It looks really familiar, 32 bits. It says add with carry IMM32, which is immediate of size 32 bits, to EAX. Well, this doesn't say much because this is just the name of the instruction, add with carry. Let's move on. Let's try the description. Adds the destination operand, first operand, the source operand, which is the second operand, and the carry flag, and stores the result inside the destination operand. This is a very good summary of what this instruction does. Maybe in some other word, this instruction just takes the first operand, the second operand, and the carry flag, and sums all the three. Then the result is stored inside the destination operand, which is the first one. What does the carry flag mean at this point? There is an explanation for that too. The state of the carry flag represents a carry from a previous edition. So this is some kind of suggestion of what we can do with this instruction. Maybe the carry flag would be the carry from a previous edition. Let's skim the text and see what more can we get. Maybe, for example, we want to know what would this instruction be good for? Why would anyone want to do this operation? You should always ask yourself those questions because usually instructions have some deeper meaning, some deeper reason for being inside the processor. And we can see it here in this sentence. The ADC instruction is usually executed as part of a multi-byte or multi-word addition in which an add instruction is followed by an ADC instruction. This is a pretty good explanation. It explains why would anyone want to use this instruction. For example, if you want to implement addition of large numbers, you could, for example, add the first byte or maybe the first D word, and then to add the next D word, you can use the instruction ADC instead of add. And the ADC instruction will consider the carry from the previous addition. It will allow you, for example, to perform addition of really large numbers. And this is just an example. Let's continue to the pseudocode, or the operation section. And indeed it is very brief this time, and it is a very good description of this instruction. We can see here that we take dest plus source plus carry flag, and we store the result of the sum of all those three into dest. I think that this is pretty cool, that you can just take a look at the instruction set and only after a short time understand a new instruction or learn about new instruction. For example, only in a few minutes we have learned about a new instruction, the ADC instruction. And we also have a good idea of what we can do with this instruction. Adding new instructions to your vocabulary is going to give you much power. So make sure to do it from time to time. Take a look at the instruction set. Become a better programmer.